Good morning. In today's lesson, we're going to work through 6 different quadratic equations and solve each of them for x using whichever method we think is best. Right now, we're focused on our 3 methods that we have for solving the quadratic equations. The first one would be the zero product property. The second one is using the quadratic formula. And then the third one would be completing the square. So what I'd like you to do, if you haven't done this yet, is to make sure you have paper and pencil out in front of you, or a copy of this document, this worksheet. And I want you to stop the video, go through, and just write next to each one of the equations the method that you, just at looking at the equation, the method that you think you would choose first. And then come back and start the video up, and we'll go problem by problem. And I'll tell you which one I think would be best. That doesn't mean it's the absolute right choice, but some of them lend themselves better to one of these 3 properties more so than another. So with that, we'll get started on this first one. And when I see this first quadratic, and I look at it, my gut instinct is to, if I can, especially when it looks like this, is to use the zero product property almost every time. And doing that means we have to be able to put it into factored form. When I look at 27, 9 and 3 jump into my head automatically, and 9 plus 3 adds up to 12. So I know this can be easily factored. X plus 9 times x plus 3. And then we use that zero product property to get our 2 results, our 2 solutions of -9 or -3. So that was a pretty straightforward one. I'm guessing most of you also chose the zero product property for that one. All right, moving on to the next one. Now this one looks a little trickier. And I'm going to go a direction probably you guys wouldn't think of going. But first and foremost, when I look at this, I would consider the possibility of putting this into standard form set equal to 0. So I'm going to do that first and then take a look at it. So I'd subtract 6 from both sides, so this becomes minus 8.8 equals 0. Now I have to tell you that in most cases I would go to most people would go to the quadratic formula. I personally don't love throwing decimals into the quadratic formula. And I also, in looking at this, I see this 0.5 and know that that could become a 1 very easily. If I doubled that number right there, I'd have an x squared, and I could use completing the square. So I'm actually going to use completing the square for this one. And I will tell you, I think this might be the trickiest one of them all. But follow along, see if you understand. I'm going to multiply by 2. I'm going to multiply everything by 2. So this becomes x squared plus 18x minus 17.6 equals 0. And then I'm going to do my completing the square step. So I'm going to have the x squared plus 18x plus something. And I'm going to go ahead and take that 17.6 over to the other side, and it'll be plus something. Half of 18 is 9. Squaring 9, I get 81. So I'm going to add 81 to both sides. Ooh, I'm going to run out of room. So then I have x plus 9, the quantity squared, equals 98.6. I'm going to take the square root of both sides. Sorry, I'm also going to move this up here so you can follow along. So I get x plus 9 equals plus or minus the square root of 98.6. This is going, I'm going to put this in decimal approximations, is approximately 9.9. So I'm going to go with that right now. And then subtracting 9 from both sides, it would be -9 plus or minus 9.9 approximately. So my solutions for x are going to be approximately negative 9 plus 9.9, which is 0.9, or negative 9 minus 9.9, which is negative 18.9. Again, you could also use the quadratic formula on this one if you're comfortable with that, and we are going to be using that on the next couple, but I wanted to show you a possibility of using completing the square. This is something that pushes a little bit beyond, gets us a little closer to what you would be doing in Algebra 2. All right, so moving on. The third one, hopefully everybody put zero product property, because anytime it's set up in factored form already, especially set equal to 0, then this is a situation where all you have to do is set the two different parentheses equal to 0 and solve. And we have our two solutions. Definitely a zero product property one. This next one's not in standard form, so it's hard to look at it and just know what we would do. So the first step is to put it in, we need to put this in standard form. So we're going to subtract 8x from both sides to begin with. And then I'm going to add 4 to both sides. So I get x squared minus 8x plus 16 equals 0. And when I see that, half of 8 is 4, 4 squared is 16. This is a perfect square. This is definitely a zero product property one. So it's x minus 4, the quantity squared equals 0, which means we really only have one solution for x. It would be 4. So that's a situation where if you guys remember, I called the b squared minus 4ac, I called that the discriminant. And in this situation, this is just a side note over here. B squared minus 4ac. If I were to use the formula on this equation over here, then it would be 64 minus 4 times 1 times 16, which is, that's my b squared minus 4ac. That would be 0. When the discriminant equals 0, there is one solution. That's the piece that's under the square root sign. So when I'm taking the square root, if I'm taking the square root of 0, there's only one answer. If I'm taking the square root of any positive number, there's two solutions. And if I'm taking the square root of a negative number, then I can't do anything. I can't find a solution there. So that's a side note. It's something that they'll bring up again in Algebra 2, but I felt that it's worth mentioning, something to think about for those of you who are understanding this and moving forward. Let's take a look at E. This one looks like, in my mind, I would think zero product property, but I got to get it in standard form first. So I'm going to put it in proper order, and then I'm going to go to factor it. Oh, but when I go to factor it, I mean, you can't have 1 and 5 is it, and they're not adding up to -2, so not the zero product property. This would be a situation where that's definitely an easy check first. But when it doesn't work, then I'm going to look at this. I could go either way. I could go with completing the square. If you guys wanted to do completing the square, you absolutely could do that right now. In fact, no, I think what we'll go with is the quadratic formula. So we haven't practiced that one yet. So in this situation, my quadratic formula, A is 1, B is -2, C is 5. So I'm just going to start plugging it into the formula. So the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. So it's 2 plus or minus the square root of 4 minus 20 all over 2. And I'm going to stop. And I'm going to stop because of this piece right here. That's going to end up being a negative number. This right here is the square root of negative 16, and we can't find the square root of negative 16. That's that situation where your discriminant is negative. That means there are no solutions. That does not mean that this parabola doesn't exist. We could graph it, we would see it. It just means it doesn't cross the x-axis. It sits above it and opens up, which means it'll never dip low enough for our y value to hit 0. So there are no solutions to this quadratic equation. This would be our answer to part E. All right, moving on to the last one, part F. For part F, I'm going to get this one into standard form first, so I need to subtract 2x from both sides. So that's negative 32x, and I'm going to subtract 45 from both sides. There is a possibility that this one is factorable, and you could go through the whole product and sum, and it would take a little bit of time, but it would be about the same amount of time as the quadratic formula. So for me, since I know this one would be difficult to factor, I think I would just go ahead and try using the quadratic formula. All right, so here we go. So A equals 20, B equals negative 32, and C equals negative 45. So X equals the opposite of B, which is 32, plus or minus the square root of negative 32 squared. I don't know if you guys have figured out by now, but honestly, you could just always call that number positive, because when you square B, it doesn't matter if it's negative or positive to begin with. That value is going to be positive. So you could just say 32 squared if you tend to make that mistake with your calculator. So negative 32, that squared, minus 4 times 20 times negative 45 all over 2 times A, 2 times 20. And now I'm going to start my simplifying. So I have 32 plus or minus the square root of 32 squared is 1024. Now, here's where you got to pay attention. You've got a negative sign or a minus sign here and a negative sign here. When you multiply those three things together, it's going to become plus 3,600 all over 40. So 32 plus or minus. When I add those two numbers together, 4,624, and take the square root, it becomes 68. That actually was a perfect square. And then divided by 40. And this is where I would break into my two solutions. I would have 32 plus 68 divided by 40, which is 2.5, or 32 minus 68 divided by 40, which is negative 0.9. So nice, neat answers, but probably not ones that we would want to go through and try and factor. Quadratic formula works nicely. You could do this one by completing the square as well. Honestly, part F, no matter what you wrote down, would be a good choice. So hopefully that helps. Go through looking at how to make some decisions in solving. And your homework assignment goes right along with that. You're going to just have some quadratic equations to solve. All right, let me know if you have any questions. We'll talk to you later.